so easier to handle. It's basically it's maybe mono, but not exactly. So I'll start with pretty primitive issues. If you're if you know there is an architect in your company, and the architect is designing your communication, like this is a, how they call it, sequence diagram, right? So what happens here? You have like a member. I grabbed it from the internet. So a member does what? Like clicks booking. Main page responds. Then the member does what? Selects facility, whatever. Leisure facility booking page response. Good. The member like clicks submit. The page immediately, or whatever, like almost immediately responds. And we select like whatever payment method, the page responds and so on. And then in the end, like we are done this booking, right? So that's what an architect will tell you, yeah, do it like this. Okay, you do it like this, it doesn't work. Whose fault is it? It's your fault. Because you didn't cover all other occasions. Like here, the member could click, or maybe it's not the member, it's a cat that clicked the key, right? Or maybe like select payment method. Oh, how do I pay? I don't have any credit cards, right? Or I don't have anything on my credit card, or whatever. This side could be like your connection breaks, your server goes down, you have 500, anything can happen, right? Comcast can like stop, communicating because you spend too much like bandwidth. So anything can happen. Does this design cover it? Can you even express it in a sequence diagram? No way. That's for like high-flying architects that tell you how to behave and will blame you if it doesn't work. So what do we do? Like you follow, you do what you are told to do, right? So you do like in Selenium, for instance, you control everything from Selenium, like I do in my applications. So Selenium load page, something, right? Then, okay, so we get this page content. Okay, good, we have a content. Then we parse it. And then we extract it somehow, like we have a function that takes HTML and finds the username. Well, it will fail most of the time, right? And more, we probably won't know why exactly did it fail, like what went wrong. We don't know. Of course, there will be probably NPs. So we can like intersperse our code. Well, that's more or less traditional Java style. So if you're like a Java programmer, you do it like this, most probably. Like if Selenium failed, okay, so we print like Selenium failed. Now we take page content. Okay, maybe it's null, right? So we print, oh, it's null. And then we do this. So what we'll have here, like one error message and then an NP, right? Because we still go ahead and check, so we probably should return something. Okay. So to be smarter, we throw some like smart exceptions, like complaint, Selenium failed, or source is null, as if it gives us something. So like this is null, that is null. Okay, it kind of works. It does what we want, but and it also reports kind of more or less specific errors. But the thing is, our code becomes so long, and again, we go down further. Okay, maybe not in this case. We like check all the errors, right? But I don't think you can check all nulls right away. So we can use option. Option, like everybody has it, like you use Squirrel. Squirrel returns an option if there's null in the database. So you can write something like Selenium load page and wrap it in option, assuming that it returns something like meaningful or meaningless. So you know what this means, right? We don't care about the result. So if like page content returns a null, so option is none, so we'll fail here and we'll return like none. Same here, if parse, well, now we assume that parse returns an option, right? Otherwise, if it returns null, we can wrap it in an option. And also, as Jane just taught me, well, can remove all these semicolons. Anyway, and then we'll try to get a value, and we assume that we return an option. So if we are successful, so we yield greetings for this username. So we return either an option, or we return either some greeting, or we return a none. But the thing with option is that we don't know. So what happened? Like none. So you call it, you run it, none. Bad. Another solution is either. So suppose that load page is now smart that it returns them either. It's either left with like a message complaint, or either it's right. So we ask for a right, so if it's left, the total response will be left. Or it's right, so we don't care about the result. So again, like we make every method, every function returns them either, and have this, and remember that right is good, left is wrong. So if you're political, we're not talking about politics. So, but of course, a load page doesn't return either, so we have to wrap it. And again, like this left and rightism could be misleading. So another solution is Scala Z validation. Well, there's also lift class box, which David was like pushing, and basically people use it not even in lift. So box is a good class. It's similar to validation. Somehow I don't have it here, but it does the same thing. Like suppose we have this method imported from validation object. So we have this like check that we didn't have any exception here. So it's a validation. It will tell us something if something went wrong. Check that this is not null, and it returns a validation. And the validation here, it all this falls to well, it's a sugar for flat map, as in the previous talk, right? So eventually we'll have this, and we yield this. But yeah, this is a good thing. So it works. It's like option, and it can keep explanation of of errors. So similarly, I wrote my I had this class for a while. I started using validation, but then something like didn't satisfy me. So I wrote more or less like the same stuff. So like for value, here it returns a result, and so on. It's like the previous one. For value means we try to call this. If it throws an exception, we graph that exception and keep it there. So we had like a bad response. If we have a null, well, result doesn't contain null. So if we have a null, the result is empty. So it could be empty, bad, or good. So in good case, we yield this. So the result of this R will be good greeting for username. So we can do this, like do match. Good greeting, so we print it or something, whatever, just send a postcard. Bad errors, so throw those errors in the log or whatever, like into a monoid. Or on empty, so we're so unlucky that we don't even have error messages, so it's empty. Like in validation, error messages are in so-called NEL, non-empty list. Well, it's just me, but I don't know how to seriously work with non-empty lists. So here I have a separate case class empty that doesn't have anything, but empty is bad, so it's not good. So you can always add like more comments to it and convert it into bad. Now let's take a look at the next example. Suppose once we have this HTML, once we have this structure, we want to extract more than one entity out of it, more than one value. So we extract this and extract this. So far, we had this like every next row depends on the previous one. That makes sense to grab the page content if we don't have the page loaded. Didn't make sense to parse the page content if we didn't have it, like if there's no mouth. But once we have it, we may need like half a dozen of different values out of that HTML, and we don't want to fail on the first missing value. Right here, like here, if username is not there, we will not like have an error message about missing date of birth, right? So that's no good, and there is a solution for that. Solution is called applicative functor. So the name is scary, but the use case is like this. So basically, what's the difference with the previous one? Instead of like doing it sequentially, we do it like in parallel. We take a tuple, username and date of birth from this. It's like this, find the value of this, and also find the value of this. Also, until like Friday, was there was this special like, how to say, sequence of ASCII characters. It's called tensor product, and it was less asterisk more. So it's tensor product. It's if you are a category, so you know, oh, tensor product. Sure, you either draw this or circle with a cross inside. If you are not a category theorist, if you don't know what monoidal categories are, well, this kind of you feel pain with the word, and also it's readable and like it shows exactly what's happening. So we find this, and also we find this. So what happens here? If we find both, we'll have these two here, so we can have greeting like for name and date of birth. If we miss something, like if either of them misses, so we have a bad. If both are missing, so we'll have this like a sequence of error, a list of errors. It could be a set, sequence, whatever. Like it depends on what we want. So the worst case, in the worst case, if we got here, so we got this and this and this. If we got here, and both are missing, so we'll have this. So we can print it. We can show it to our like whoever provides us with this bad HTML. Or maybe tell the developers, like, maybe it's not date of birth actually, like, it should be capital or whatever. So, but anyway, we see all the errors, like, when you compile. So, this is how you can analyze the results. Like, we have props, so some properties extract this and extract this. Both are results. And we can match it either with good, and here like this string and this string, most probably a string, right? Of bad with a like list of errors, or empty, like previously, but with a couple of values. And of course we can wrap it so we can have like a bunch of these values from inside, and report if they're missing, have a list of missing values. Well, that's basically all that we need to know about applicative functors. You have this, you can apply it, and you can extract the data in parallel and be happy about it. But now I'll be like kind of talking more about this result class. So suppose we call this, we have a suspicious function, and something happened there, like an exception. So what we have there, like good, it's no good. But since we call for value, so it's like try class. We have probably bad, right? And bad, usually if you just print that bad, you'll see error message. But there's a method that you can call if you want to investigate really what's going on there, what happened there. It's a stack trace. So imagine like you ran like a bunch of like queries, and some of them failed, and you have a list of errors. And you can investigate, like we had that stack trace here, had that stack trace here. So we keep it in one place, and maybe we add more complaints about it. So for me, like it's a pretty convenient thing to investigate. But again, who needs stack trace, generally speaking? Only when you are really investigating like what's going on there. Generally speaking, a good error message would be enough. So errors that I was showing before, the thing that is hiding inside bad. Okay, it's a mono. So it's just a traversable of throwables. So generally speaking, if you stringify it, you only get messages, but you can go deeper and get stack trace. And stack trace, I heard it could be like more expensive to extract than just stringification than messages. So it's not by default. And again, nobody wants stack traces in their logs just on every like missing file or whatever. So at times you run stuff and you don't care about the result, like the values. You only care about success or failure. So ignore this. This is kind of a little bit weird, but this. I have this funny type where I don't care what's inside, like whatever calculations I do, the result is an outcome. So a good outcome is okay, which is just good okay. Well, it's a symbol, right? So when I do my stuff and I don't care about things what's inside, I return okay, this okay. So that's all I need. But if there's an error, yeah, here. It's basically kind of like catching exceptions in those in old days. And instead of question marks, I also have this not implemented that calls this oops. And yeah, since it's an error, so it also keeps, well, it can return stack trace if we need stack trace, because it's an error. So that's how you can do it if you don't care about results. And of course, you can combine things. So this is like a piece of source code. So we have a result. It returns some booleans like is good, is bad. Well, booleans are not supposed to be like a good practice in programming. So like Haskell people say, don't use booleans. Yeah, I try to not to use booleans either. So list errors, just return those errors if there are any. It's traversable, so empty list of errors if we are good. Instead of extracting list of errors and so on, we can do like on error and do some operation. So like it's continuation passing. Map is already, you saw it, map and flat map. If you do for comprehension, so it's the same thing, right? Doing map on a functional flat map where like we return another result and flatten it. And then we call and then if we don't care about the previous result. Like you had okay, 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 and then, and maybe eventually you get something that is meaningful. It's basically similar to having a for loop with underscore arrow. Collect, so its result is not iterable, it's not even traversable once. So that's an interesting issue. Should it be traversable? Can it be used together with a list? Well, I prefer not to do it. I prefer if we have a list of errors. So better like scan the list and then inside do internal loop. So loop inside loop, not just have it all like flattened. So collect is for if you have a partial function that is defined on some values but not defined on others. So we run this collect and get the things that this partial function produces. Of course, we can convert it into option if your like code requires an option. So, or else means we had like a value in a result, but maybe if it's not, it doesn't satisfy. So there is another like alternative. So with this result or else other result. But there is getter or else. So we extract the value hidden inside good. If it's not good, so we fail. So if it's not good, then we take this value. See, there is no get, like option. I don't know why option has get. But this is an interesting feature, like class option has get and it throws an exception. It's like Haskell, so let me do some Haskell bashing. You know that in Haskell lists have a method called head. So what's the head of a list? Like it's supposed to be, what, pure function, right? What's the head of a nil? And when I talked to Haskell people, they said, oh, that's legacy. So okay, so legacy is really like all around. So that's why option has get, because if you come from like non-functional world, you always ask, so how do I extract the value from outside, from inside? Well, you don't, because it's not like it's not the value that you have. A monad is not a container. It's like you pass something to process the value, like with state monad that James was talking about, like here, so you can do this. But on the other hand, if you have an alternative, yeah, you can do it. So for each is basically the same. If there is a value, we do something with that value, that's it, and we don't care about the results. You can of course have filter like in any option or whatever, any iterable. You can have filter and like on error say something like explain why you're not happy with when it's not filtered. So fold is, well, I wouldn't say I love this function fold, and I rarely use it. So what happens to action? And it's similar to what you usually do in JavaScript, right? In JavaScript, like when you do XML, how they call it? XML HTTP request, so there are two reactions, like good and bad. So this is what you do when it's good. No, when you do when it's good, and this is what you do when it's bad, and you return something in any case. So maybe it's a result on both occasions, maybe it's something. So that's what fold does. And or comment the error. It's a pretty convenient thing. Look, in your code, you like extract something from you call like read something from the web, extract something from HTML. But if it doesn't return, you should like have a reasonable explanation why you're not happy with that. So you write like you get something or comment the error, and then your message, your text about like what you don't like about it. And then eventually, if something fails, so you have like a pretty good text explaining what's going on. So that's what I use all the time. Again, on bad, on good, it doesn't do anything. On bad or on empty, especially if you get an empty, like you transform option to result, so you have empty. What there? I mean, you get empty if you have none. But you can also add or comment the error and then explain, oh, this none is no good, this empty is no good. We expected this and we got that, something like that. So, and of course we can take an option and return a result with the obvious functionality, right? So try. If it succeeds, we have a good. If it fails, so we had that bad with that exception, with that failure in try. Future. I believe this is lazy, so as soon as you try to do something with the result, it's called futures get, and it may fail, so we'll have that bad, but if it doesn't fail, we have that good result. And either is here too, but left is a string, so that's all we know. But what else can we do? Like it's just an error message there. So now what if we have like a list of results? Having them in the loop is kind of weird, right? So we have two functions for that. I'll talk about second one first. So suppose we ran through like a bunch of websites, extracted like the value from here, value from there. So we have a plurality of results. And then, but all you need is either the sequence of good stuff, and it should be good, or explanation of errors. So what happened? So that's what happens here. We walk through all these results, collect errors, and if there are no errors, we have good traversable. This is basically like, how they call it, monad transformer. Monadic transformer for these two monad traversable ones and result. Partition is like slightly different thing. So again, if we have a bunch of results, maybe we want a list of successes and a list of errors. So that's what's happening here. Here we collect good stuff, and here we collect bad stuff. So the result is a tuple, and we are already not in result because we know all these guys are good, and we know all these guys are bad. Yeah, and you can convert it on the other hand into this, depending like whether there are any errors. So that's it. Any questions? Like, should I go back or whatever? So this is like a practical stuff that I've been using like for the last more than a year and a half, gradually like throwing in.
Do you have a snippet of the real code?
Yeah, I can show you some in my code. Let me see. Give me a second. So, let me zoom. Doesn't allow, so okay, so I don't know if you see it from here. So we extract from props, we extract PDF, which is probably a URL, right? And build a URL here. So we have one thing, one result. The other result is we extract reference number from properties again. And again, we have this date, optional date, which is the value of this. So it's like it parses, and actually it's a date inside the result. So we have this. The result would be URL and claim number, reference number, right? And date. So unfortunately, see, this is a pair with a tuple with a tuple inside. So I don't convert it into like a triple, a tuple of 3 elements. That's like somewhere in the future. But anyway, so we have this, and we get the result, and if we are good, so we do something here. Otherwise, it's an error, so we'll have this result listing the errors, what we got. This is like not something that is not in the loop. Usually I use it in the loop, so let's see. Yeah, like here. Yeah, this is a typical thing. I would not say it's like so perfectly readable as I'd love to, but so we have this like find claim number, find account ID, find date of service, and so on. And it's all wrapped together and mapped into this claim number, account ID, date, provider info, kind, status, insurance, and they're all extracted like in parallel. And again, I will replace this less star more with, and also probably tomorrow, so to make this stuff more readable for my colleagues. So that's how it works. Anything else?
So, Vlad, if empty is always bad, what drove you to make that a separate type instead of making
The
bad?
thing is, it doesn't contain any error information. So, let's see if we ever use it. Yeah. So we traverse stuff and found nothing. But you traverse an empty list. What you get? Empty result. So it kind of makes sense. Because, yeah, suppose you have this like a list of results, right? And you traverse. Empty is a totally different value. So it's not neither good nor bad. It's just, well, it's not good. So like if you check for good, it's not good.
Okay.
If you check for bad,
So it's not strictly bad, it's just
yeah,
not
yeah.
good.
So I would not say like I can explain this, but I found that I cannot seriously like deal with the stuff without it.
Okay.
I would not say I have like logic behind it.